Hey kids, it's Dr. Runce with the first lesson of Chapter 5. This is kind of an exciting lesson where we're going to, an exciting chapter where we are going to apply what we learned about slope-intercept form to a variety of different situations, some challenges or puzzles you might think of them. This first lesson, however, is kind of a summary of some of the things that you've already learned. Just a slightly new variation on a skill, but truly this is kind of a review. It's an important one, and this is our launching point for our next several lessons. So we are going to use the slope-intercept form of a line so that we can write an equation of a line. So previously we have done the reverse of this. We have we have graphed a line from an equation. So now we're going to derive an equation from a line that's on a graph. So just as a review, just so I don't leave anyone out, remember in y equals mx plus b, the b is the y-intercept. Of course, this is right where the line crosses what axis? The y-axis. Okay. Hopefully you know that really well by now, but if you don't, now you have a reference. And then m represents what? Slope, right? This is the slope, or represented with m. It can be represented in a lot of different ways. It could also be the difference in y over the difference in x. Makes sense because y is vertical, x is horizontal. You can also think of this in the equation to find slope, y2 minus y1 over x2 minus x1. It's also referred to as rise over run. And what we do write on a lot of our papers is the up and down over the left and right. Up and right are positive, down and left are negative. And so again, hopefully that's a review for you, but it's good to have it all in one place. And we added a Mr. Slope guy, give him a mohawk just for fun, so that you remember him as well. Positive slope, negative slope, undefined, there's a U, and zero slope. Eventually you'll have those memorized very thoroughly and you won't even need Mr. Slope Guy, but for now he's there for you. Okay. Let's do some examples. I think you may also know this already. So if I have this equation y equals 3x minus 2, what is the slope? That's 3. Intercept then is negative 2. Great. Next one. Y equals y equals x plus 4. What is slope? I hope you didn't say 0. It's 1. This is a singular x, and a singular means 1, right? And our intercept is 4, positive 4. Okay, y minus x is 3. Remember, we can only pull slope and the intercept from an equation written in slope-intercept form. So first we must make sure this is in slope-intercept form. Slope-intercept form is literally y equals, not multiple y's, not a negative y. It's literally a positive singular y on the left equals, then x plus 3. And now please write your slope and your intercept, which should be 1 and 3. All right, take a stab at that next one. Go a step ahead of me, see what you can do. And then did you add 6x to each side to get 3y's are 6x less 3. And then what must you do? Divide by 3. To get y is 2x minus, did you do it right? 1, that's right. 6 over 3 is 2. Negative 3 over 3 is negative 1. So then your slope is 2, and your intercept is negative 1. Good. All right, hopefully that wasn't too bad for you. Let's move on. I'm gonna try to move my tripod. My tripod got goofed up, and so it's not as mobile as it used to be. I'm sorry if I'm making you dizzy. Okay, so this is the new little variation. It shouldn't be too hard here. It says to write an equation of a line if, and again, these equations are going to be in slope-intercept form. So y equals mx plus b. Well, if we're told that the slope is -2 and the intercept is 5, then we can say an equation for this line would be y equals -2x plus 5. You know, take a second and see if you can visualize that. I know that we're just writing these equations, but it's kind of neat to force your brain. So what would that look like? So about 5 up, I'm just estimating, and -2. It looks something like that. It's probably not to scale, right? But it's good for you to know, you know, this would be a positive intercept, so it'd be up here. This is a negative slope, so it'd go like that, right? Okay. All right, back to what we were doing. Slope is 3, intercept is -2. So then the equation of the line would be y equals 3x minus 2. Okay, hopefully this is pretty easy for you. How about the next one? Y equals 5x plus 0. No. Okay, so this is the correct value, but only this is the correct form. Don't write plus 0. Makes you look kind of silly. Okay, try the next one. Y equals 1x plus 3. Correct value, but isn't it redundant to say 1x? So drop that one and just write y equals x plus 3. Okay. All right, so far so good. I think you're probably doing pretty good. This is where it gets, I'm not gonna say difficult, just a little bit more, slightly more difficult. Ah, so sorry. Oh my goodness. Okay, so we are going to write equations from a graph. So sorry. Okay, so here is a graph, and from this we are going to find the information that we need to write this in slope-intercept form. So first of all, we will find the slope. Remember that we can count out the slope. We haven't done this much. Let me back up even further. Now I could find the coordinates for each of this. So this is 1, 2, 3, 4, 5. This is point 1 and 5. And this is point 0 and 3. And I could do y2 minus y1 over x2 minus x1, but we don't need to do that. We can just count the rise over the run, or the vertical distance over the horizontal one. So let's say I'm traveling from here to here. And it doesn't matter which one you start with because it'll be the same slope. Also, it doesn't matter which points you use. So these points were given to you just for the sake of ease of the notes, but you could use any points that clearly go through the grid lines. It doesn't matter which 2 points you use. It doesn't matter which direction you go in. You'll get the same solution. So in this here, say I'm going from here to here, I'm traveling first up 2. So 2 in the numerator, because that's the up and down. And if I'm traveling up 2, that's in a positive direction. And then after that, I'm going to travel right 1. A positive 1 in the denominator goes to the right. And of course, simplified, 2 over 1 is 2. Okay. And then our intercept is at 1, 2, positive 3. So just like what we were doing on the front, we can now write an equation in slope-intercept form. Y equals 2x plus 3. Cool. All right, let's try another one. Okay, so you can see right away that this is going to have what kind of slope? It's going to have a negative slope, isn't it? Okay. Feel free to pause this and try it on your own before I walk you through it. Okay, so I'm going to travel from here to here, just for fun. So I'm going to travel 1, 2, 3 up. Up is positive, over 1 to the left. Left is negative. Now let's see if I would have done that the other way. What if I had gone 3 down? Down is negative. And then 1 right. Right is positive. Do you see how it's going to work out to be the same thing? Negative 3 over 1, 3 over negative 1, they're both negative 3. And then the intercept is at 2. So therefore the equation would be y equals negative 3x plus 2. Great. Okay. All right. So now we have a positive slope again, and you can see if you're comparing it to the one above it, the one above it has a much steeper slope than this guy. Okay, again, feel free to go ahead of me to find this slope and the intercept. We're going to travel from here to here. That's positive 1 over positive 3, which makes sense because this is a positive slope. The intercept is at negative 2. So then the equation would be y is 1/3 of an x minus 2. Great. Okay, try the next one without me. You can do it. Okay, did you really pause it and come back? If you didn't, actually pause it and try it. Okay, here we go. So I'm going to travel 1, 2, 3, 4, 5. Gosh, this is tiny. My eyes are old. And right 2. I actually have laser vision, so I can't even complain. Okay. So 5 over 2 is my slope. Don't simplify to 2.5, because if you did that, a slope of 2.5 doesn't really help you if you're graphing the line, right? Okay. What's the intercept? What's funny about this? What kind of situation is this? Did you say direct variation? You make me proud. Okay, so is that right? Just leave this. Drop the +0. Okay? All right. Ooh, the next ones look tricky, but you can totally do them. Okay. So, what is the slope? Do you remember? A horizontal line has a slope of what? Do you remember Mr. Slope Guy? He has a horizontal mouth, and his little dimples are, yeah, zeros. This is a slope of 0. There's no slope to this line. It's perfectly flat. And the intercept is at 2. So if I wanted to write an equation, I could say y equals 0x plus 2. Is there something that kind of strikes you kind of funny about that? Yeah, we don't need this. We can just say y equals 2. 0x is kind of funny, so we drop it. Here's a really important thing for you to learn. A horizontal line is always going to be y equals some number. We've talked about that briefly in the past, but again, it's good to have a reminder. Okay. So knowing that x and y are opposites, what do you suppose the one next to it is? Woo! So sorry. Okay. Did you say x is 3? Okay, but let's talk about y. Okay, what is the slope? It's undefined. And what is the y-intercept? Well, there isn't one. So the slope-intercept form isn't going to work because there's no intercept. So that is why this is the only situation where your equation is going to lead with an x. So a vertical line is going to be x equals some number, and that number will be where it crosses the x-axis. Okay. So that's good stuff for you to know. I recommend that you maybe put a star by it so you see it later if you haven't committed it to memory. Okay, great. And remember, the greater the slope, the steeper a line. We learned that from the very beginning, but again, this is kind of, a refresher, putting the key points all in one place so that you have basic information moving forward. Actually, this might be review, it might not be, but just for the sake of clarity and Mrs. Rones being fair, let's just go over some. I'm going to call them Rones' rules, but really this is going to be for all of your math teachers. So I like to be tough on you now so that when you go forward in life, you look as smart as you actually are. So cool. All right, so there's something wrong with each of these. Let's look at them. What's wrong with this guy? We talked about this already. Yeah. So instead of 1x, we just write y equals x plus 3. We don't need that. How about this plus minus? When you have a positive and negative together, I'll just keep the negative. Y equals 4x. So the intercept is at -6. Okay. How about this? Now if you had to graph this line and it was y equals 0.75x plus 2, that's not helpful, right? So I hope you know that 0.75 is equivalent to 3/4. If you don't, I suppose you could do 75 hundredths, 75 over 100, and simplify that down to get 3/4, like so. Okay, how about the next one? This one's a little bit more subtle. Give you a clue, the problem is here. So there's nothing wrong with this. If this is your intercept, and I tell you that your intercept is at -3/2, it's not super helpful. It should be -1.5, and then you know where to put your intercept. It'd be, those intercepts are kind of annoying because they're halfway through the box. Okay, how about the next one? What's the problem? This can be simplified down. This I see actually pretty commonly because, let me write it down and then I'll talk because I'm not good at doing both. People will often do that over 1 when they're graphing to remind themselves that it's going to be up 7, right 1. But when you're writing an equation, don't write that over 1. Okay. All right, next column. Hopefully you saw this right away. This was previous in our notes, right? So y is 6x. Okay. How about the next one? Yeah, it's this here. Right. That's not helpful for our slope. We need it to be a fraction. Improper fraction is fine. So this as an improper fraction would be 2 times 1 is 2 plus 1 is 3. Or if you have 1.5, that's a total of 3 halves, right? Good. Okay, next. Did you see it? Y is 3x plus 3. So does that mean we change this as well? As long as it simplifies to a whole number, go ahead and do so. So y equals 3x plus 2. But, so let's look at this one here. This is where it gets kind of messy. So I get that this is, what, 2.5, right? But that is kind of like this, right? It's not helpful. But 10 over 4 can be simplified into what? 5 over 2. A slope of 5 over 2 repeated twice, right? Up 5, right 2, up 5, right 2 is the same as up 10, right 4. Yeah, so they mean the same thing. This is the more simplified form. Okay. Great. I hope you found that helpful. I hope you also found it informative, not boring. good reminder, good refresher moving forward. This is what we are going to build on moving forward. Okay, so let's do some practice. Practice makes perfect. We're not striving for perfection, we're striving for learning, but practice makes learning. Okay, whatever. Stop talking, Let's just teach the lesson. Okay. I'm going to try to zoom in so you can see. Hopefully you have this in front of you as well. Okay. So for this first section, you are to find the slope. What's the letter for slope? Slope. And y-intercept is, yeah, B, the line. Now remember, this only works if you have an equation in slope-intercept form. So if it's not in slope-intercept form, you need to write it in slope-intercept form. So I don't want to steal one of your only 6 examples. Oh, and sorry, maybe I won't look at the B. Maybe I will give you an example. Sorry. So number 1, M is what? 2. And B is what? 5. Good. I don't want to give too much away. Yeah. Yeah. Resist. I'm not going to give you more help than that because I think you can do it. I think you can do it. Yeah. Okay. I'm so tempted. I'm not going to do it. Okay. For 7 through 18, writing an equation of the line, this is where I strongly recommend that you keep on hand those rules that we wrote at the very end. Ugh. Fit. Because it could be that you write an equation with the correct value, but in the wrong form. So I would not accept y equals 1x plus 0, because now you know better, right? This should be y equals x, and that's all. Okay? All right. So that's what I would like to see. And then at the bottom, this is where you're just going to write equations of the lines. None of them are too tricky, but you'll notice that there are no dots on there like your notes had. So you can choose your own dots, and it doesn't matter which dots you choose. So like in 19, you could choose this dot and this dot. Or you could choose this dot and this dot. It doesn't matter. You're going to get the same thing, and it doesn't matter if you go from here to here, or if you go here to here, you're going to get the same slope. I recommend using ones that are close together because then you don't have to simplify, but you do you. This one's kind of hard to see in 21. This is your line. It's a special kind of line. If you've forgotten, you can look at your notes. All right, so I hope that's helpful for you. I didn't do my disclaimer at the beginning. You know, my lessons aren't perfect. Every math teacher is going to teach it a little bit differently. I sure do my best. If I have lost you, please do not hesitate at all to email me. Oh, I'm going to run out of room. You're never a bother. Happy to help. All right, thanks guys, and I will catch you back in class. Bye.